Okay, so we're going to change it to a nice base. Okay, so this one here, this base 4 and the argument 8 are not quite compatible, although there is a related base that we could use. And the related base is base 2. So we can use this to convert it to base 2. Now, I could convert to base 10 and use my calculator, but really, if I convert to base 2, I don't need a calculator. So I'm going to say that this log is equivalent to log base 2 of 8 over log base 2 of 4. So that's what my formula says up here. Right? I take the log of the argument divided by log of the base. And I can use whatever base I want. In this case, I use base 2. Well, I know that the exponent on 2 that gives me 8, that log is equal to 3. The exponent on 2 that gives me 4, that log is equal to 2. Okay? So what that means is that this must be the answer to that log. Well, if that is in fact true, we can test this. We have this expression, log base 4 of 8 equals 3 over 2. That means we can convert this to 4 to the power 3 over 2 equals 8. If I try this on my calculator, okay, 4 power bracket 3 divided by 2, yeah, I'm getting 8. This checks out on my calculator. Okay, I'm going to do another calculator check here. And this is how we often use change of base as well. Sometimes we want to use change of base to be able to type things into our calculator. So my calculator has a base 10 button. So I'm going to use a change of base formula here. And I'm going to change this into log base 10 of 8 divided by log base 10 of 4. Now this is ugly because log base 10 of 8 is an ugly number. Okay, so log 8 is like 0.903 something. It's an ugly number. But if I divide that exact value by log of 4, okay, log 4 is a really ugly value as well, but together they give me exactly 1.5, which is same as 3 over 2. Okay, so there's 3 different things here. We have change of base formula applied with the common base 2. I just checked it here, and here I had change of base formula with that base 10 that I can use on my calculator, and it gives me all the same results. So looking at this one here, we can do the same thing. If we look at that question there, if I look at the argument in the base, there is a common base 5 involved here. So I'm going to use a change of base formula, and I'm going to use it to base 5, because if I have base 5 and base 5 log, I can evaluate this without a calculator. Okay, because I just have to ask myself, what exponent on 5 gives me 1/5? Well, that exponent is -1. Some power of 5 gives me the argument 25. That's power 2. So that's my answer. So log base 25 of 1/5 equals -1/2. And again, if you want to check it, we can check it using the exponential form. 25 to the power -1/2 equals, well, negative is in the denominator. 1/2 means square root. Yeah, that's perfectly fine.